joint and marginal distribution. As you wish. First one for discrete case, that means we have two random variables. Now joint and marginal we will discuss for two random variables. So we require a minimum two random variables. So let x and y be two discrete random variables. Be two discrete random variables. So x takes the values, random variable x takes the values in this form x1, x2, xn, and a random variable y takes the value in this form y1, y2, and ym. So the order pair of random variable we define as xy. The order pair takes values in this form, that means order pair of x1, y1, order pair of x2, y2, x3, y3, and xn, ym. So the joint probability mass function, that means in discrete case we use joint probability mass function. For continuous case we use joint density function, probability density function. So probability mass function for discrete case of x and y is the function f of xi yj, So giving the probability of the joint outcome So the joint outcome, that means x equal to xi and y equal to yj. So y is equal to yj. So we can understand through. So this is random variable x and this side random variable y. So y having value y1, y2, ym, x having value x1, x2, xn, and the function, that means for order pair x1, y1, we define function as x1, this one x1, y1, this is x1, y2, and x1 and ym. Similarly, x2, y1, and this one x2, y2, and x2, ym, and so on, and that means xn, y1, xn, y2, xn, ym. The sum of the probabilities, that means this is pi. Here is the total of the probabilities, that means we do the sum. So this is P1, P2, and corresponding PM. Here is P1, P2, PM, and the sum of both are equal to 1. The sum of all the probabilities is equal to 1. So we can get as summation of iota is equal to 1 to n and the summation of j is equal to 1 to m. Probability p of xi yj is equal to 1. So joint distribution function of x and y we define as joint distribution function of x y. We define as a function of xy is equal to probability of x less than equal to x and y less than equal to y. Y less than equal to y is equal to summation of. So u being a variable which is less than x and summation of v less than equal to y function of uv. Function of uv. This is for discrete case. And we talk about continuous case. For continuous case, we have given an interval. We have given an interval. So that means random variable x takes the values between a and b, and random variable y takes the values between c and d. Between c and d, and order pair. So the order pair, that means of random variable x and y, takes the value of Cartesian product of A, B, C, D in this form, and function fxy here small fxy giving the probability density function, that means probability density at xy. Probability density at xy. So joint probability density function we define as, that means this is x origin, y, x having value a to b, x having value a to b, y having value c to d. So we make a rectangle in this form. Okay, you do the taking this side. Taking b here. So we take a small portion, that means for finding the area. Dx and dy, length and width. So the probability, when we write the probability of this function, so which is equal to, for two variable function fxy and dx into dy. So area of this is dx dy. So when we calculate, so f of xy into xy is equal to probability of x, random variable x lie between -20 to x, and a random variable y lie between -infinity to y. So this equal to -infinity to x and -infinity to y. So function of xy dx into dy. So for this function, probability density function, we already discussed above. So the value of fxy value of fxy should be positive. This is the necessary condition for the function. And the second, the total probability. So the total probability should be 1. Total probability is 1. The total probability is 1. So we can express in double integral form. Area. In two-dimensional case, we calculate the area. For three-dimensional, we calculate the volume. So we take the small rectangle portion. So taking the width and length. So area of rectangle is length into width. Dx into dy. So this we can express as a to b c to d fxy dx into dy is equal to 1. Some of the probabilities under the given interval a to b or c to d is 1. Or we talk about the general case. So when you take limit minus infinity to infinity, fxy dx dy is equal to for general. Okay. So when we talk about the marginal distribution function, for marginal distribution function, we extend this. That means when we take interval a b c d, so take the product of a b c d. So marginal distribution we calculate separately for random variable x. So when you calculate marginal distribution for random variable x, so you take the limit of y c to d fxy into dy. And when you calculate for y, so you take the limits of x. So fxy into dx. So calculating for x, taking limit as y. For calculating y, taking limit for x. Or you can write as marginal distribution f of x less than equal to x. Then probability of x less than equal to x. So for this we can write as x less than equal to x and y less than infinity. Y less than infinity. So we can write as limit y tends to infinity f of xy into xy. So this equal to f of xy into x of we replace y as infinity. So function of xy, that means for joint distribution function you put as y equal to infinity, and for case of y you write as y less than equal to y. So this will be I directly. So in case of x, x is infinity, and we write as y. Just so this fxx is the marginal distribution of random variable x. This fyy marginal distribution of random variable y. Or we talk about the both the cases, that is for Marginal distribution case or above case? We are finding marginal distribution of x. So the random variable x taking as less than infinity. Less than infinity means you consider marginal distribution for x variable only. That means random variable x only. So that's why we put a y as to infinity. We take one example so you can understand with the example. For continuous case, marginal distribution of random variable x we write as minus infinity to x and minus infinity to infinity f of xy and dy or dx and fyy. This will be minus infinity to y, just x replaces y, minus infinity to y or minus infinity to infinity fxy. This is the integration for x. So we take one problem related to that. If x and y two random variables having joint density function fxy equal to 1 upon 27 into 2x plus y, where x and y can assume the value only 0, 1, 2. Find marginal distribution of x. So marginal distribution of x, so that means this is the case of discrete random variables. So x also consider only three values, random variable x. Consider only three values 0, 1, 2. Random variable y also consider three values 0, 1, 2. So when we construct a joint probability distribution function, so the table for joint probability distribution here we take the value of x and this side we take the value of y, this side value of x. So y also read only, that means taken value 0, 1, 2, x also taken 0, 1, 2. Function is defined as fxy is equal to 2x plus y upon 27. So when we put x equal to 0, y equal to 0. So the function gives us 0. When we put x equal to 0, y equal to 1, the function gives us 1 upon 27. So when we put x equal to 0, y equal to 2, so function gives us 2 upon 27. So similarly, that is second value when we put x equal to 1 and y equal to 0. So this gives us 2 upon 27. So when we put x equal to 1 or y equal to 1, the 2 plus 1, 3. So this is 3 upon 27. When we put x equal to 1 or y equal to 2, gives us 4 upon 27. So x equal to 2, 2 to the 4, 4 by 27. X equal to 2, 2 to the 4, 4 plus 1. So this is 5 by 27. X equal to 2 plus y equal to 2, the 6 by 27. So this is 6 by 27. So when you want to calculate the value, that means marginal distribution of x. So marginal distribution of x, so you write as marginal distribution of x in this column. So just do the sum of the values. So that means marginal distribution of x. So x means x equal to 0. So marginal distribution of x is 3 by 27. Marginal distribution of x equal to 1. X equal to 1, so do the sum. Sum of 2, 3, 5, 4, 9. 9 by 27. And marginal distribution of x equal to 2, which is 4, 5, 9, 9 or 6. 15, 15 by 27. So these are the answers. So that means we have the formula marginal distribution of x, random variable x for a value x, which equal to we write as summation of y f of xy. So f of xy, this means when we write as x equal to 0, so we do the sum of the function values which equal to 3 by 27. So this is for f of x equal to 0, this is for f of x equal to 1, and this is for f of x equal to 2. So these are the marginal distribution for x. And correspondingly, we also calculate the marginal distribution of y. So you can write the sum, marginal distribution of y. So here is 6 upon 27. This is 1, 3, 4, 5, 9, 9 upon 27. This is 2, 4, 6, 6 or 6, 12, 12 upon 27. So this is for marginal distribution of y. So that means you can write as y. So this is answer for marginal distribution of y. Okay, got it? So this is the case of addition. That means a discrete case. For continuous case, we use the integration. So we take one example for continuous case. Okay, very good. So continuous case. So joint probability density function of two random variable, function of two random variable, x and y, is given as f of xy equal to 9, 1 plus x plus y upon 2 into 1 plus x raised to the power 4, 1 plus y raised to the power 4. And the limit of x is 0 to infinity, and corresponding y also 0 to infinity. Y also 0 to infinity. So find marginal distribution of x. So this means this is the continuous case. You can create the difference of discrete and continuous. So continuous, that means interval is given, and the discrete case the values are assigned. That means x having only 0, 1 or 2 value for the series. And here is the interval. So calculate marginal distribution of x. Marginal distribution of x and set y. So marginal distribution of x, so we have the formula f of x, so that means limits minus infinity to infinity. We write here for uh, double integral case, but in single you can write the formula For single case, I also mentioned that that means when you calculate single, so this equal to minus infinity to infinity fxy into dy. For x, that means y lie between minus infinity to infinity, or for y case, fyy equal to minus infinity to infinity fxy into dx. So here x lie between minus infinity to infinity. So when you taken single integral, so we taken a single integral, that means minus infinity to infinity, but in function is defined from only 0 to infinity. So we take limit as 0 to infinity. So 0 to infinity f of xy into dy. So you can write as 0 to infinity f of xy. Function is this. So we write as 9 1 plus x plus y, and twice of 1 plus x raised to the power 4, 1 plus y raised to the power 4 into dy. So integrate this. So during integration, when we are doing integration with respect to y, so when you are doing integration with respect to y, that means the x variable treat as a constant. So we take outside. We take outside the x from, so 0 to infinity. 1, 9 also we taken outside. So this is 1 plus x. So we do not write 1 plus x, we write as 1 plus y plus x. Numerator function we can write in this form. And 1 plus y raised to the power 4 into dy. So 9 upon, when you integrate with respect to y, so x treated as constant because we are taking single integration. So we can write this as separately, 1 plus y upon 1 plus y raised to the power 4. So this gives us 1 plus y raised to the power 3 plus x upon 1 plus y raised to the power 4. So what is the integration of 1 upon x square? 9 upon 2 into 1 plus x raised to the power 4. When we do the integration of first term, this term is x raised to the power 3. Suppose, so we can write as x raised to the power minus 3 plus 1 upon minus 3 plus 1. So this means x raised to the power minus 2 upon minus 2. So this is minus 1 plus y square. The integration of this term. Understand? And same, x treated as constant, and 1 plus y raised to the power 4. So minus 4 plus 1 upon minus 4 plus 1. So minus 4 plus 1, so this gives the negative sign. Minus 4 plus 1 is 1 upon 3. 1 upon 3, 1 plus y raised to the power 3. And taking limit 0 to infinity. So this equal to 9 upon 2, 1 plus x raised to the power 4. And when we put y tends to infinity, so infinity ka square infinity में something we add in infinity they give infinity, or something upon infinity 0. So same as x upon infinity, something upon infinity 0, or for lower limit, so lower limit we put as y equal to, this gives us 1 by 2, and here also plus x upon 3. So when we put x in lower limit x equal to 0, sorry, y equal to 0, so gives us 1 by 2 plus this one. So something upon infinity is 0. So 9 upon 2 into 1 plus x raised to the power 4, and taking LCM 6, this is 0 and this is also 0. So when taking 6 LCM, so 2 3 are 6, 3 plus 2x upon 6. 3 plus, so 3 3 is 9, 3 2 is 6. 3 3, so this is 3 4 upon 4, or 3 plus 2x upon 1 plus x raised to the power 4. So this is the marginal distribution of x. Similarly, uh, we see that there is no need to solve this problem for y. Why? We see that the function having symmetry, x की power 1, y की power 1, 1 plus x raised to the power 4, 1 plus y raised to the power 4. So on the basis of symmetry, you can write directly answer. So that means marginal distribution of y. Marginal distribution of y is equal to 3 by 4, or in place of x we just replace as y. In place of x we replace as y. So this is the answer. Okay. Hope you all are comfortable in integrations. Nitesh, Shikha, Devangini, Ashmita. Okay. All are from BSc or okay. Okay, okay. So last question, and the joint PDF is given. Okay. Fxy is equal to 4xy. The limit of x is given as 0 to 1. Limit of y also given as 0 to 1, and 0 otherwise. Function is defined 0 otherwise. Calculate expectation of x, expectation of y, expectation of xy, expectation of x plus y. Question can be asked.